Hello everyone, it has been a while. Welcome to this video in which we will cover Model 3 of the math models of the GAT Qudurat English book. Now, if you haven't checked the previous two models, be sure to check out my channel. I will try to link them in this video. Also check out the description. There you will find my email, send me some questions or literally anything. And then you will also find my PayPal. I would appreciate your donations, which have also helped me get this very professional sounding mic, hopefully. And I hope this video is helpful. Enjoy and let me know what you think in the comments. Alright, now starting with the first question. We have if x plus 1 over x is equals to 2, then x to the power of 2 plus 1 over x to the power of 2 is equals to what? This is what it actually looks like, but typing it down looks like this. So we have x plus 1 over x equals to 2, and x squared plus 1 over x squared is equals to what? Alright, so there's definitely a formula in order to solve this, but let me just show you guys how to do it using logic. So we have x over 1 over x, so these numbers are the same number, and same thing applies here. So now you can just think of it as what number that is added to 1 over the same number that's going to give you 2. So just maybe start plugging numbers, or even, of course you can't use this because we're not looking for the number here, we're looking for the answer of this. So, or for example, you can start 2 plus 1 over 2 over x. I always like starting with 2, and that does not equal to 2, right? So in this case, for example, then you know that if you keep adding, so if you put 3 plus 1 over 3, that's not going to be 2, and so and so. So you go down. So you go 1 plus 1 over 1, which is equals to 1 plus 1, which is equals to 2. So 1 works here, all right? Now this won't give you the definite answer because now we're going to plug it in and it will work, right? Because 1 squared is just 1. So this works. So we have that 1 plus 1 over 1 again is going to be equals to 2. So that's the answer. But you will not always find the answer using this method. Why? Because you can use it and 1 will work, but then you won't find whatever the answer to this is here in a different example, let's say. Why is that? Because maybe that's one answer. There's another answer that they're actually looking for. So there has to be an official way, but for the GAT, and as far as my experience, this always has worked for me and hopefully will always work for you. If you know of the formula to use, please put it in the comments below. Moving on to question 2. Compare the value of a, which is 3x to the power of 0, and here it's telling you that x does not equal 0, or the value of b, 5x in between parentheses to the power of 0, and x also doesn't equal 0. Sorry about that. Should have added it earlier, but we can do that right now. Boom. So how do we deal with this? This is what it actually looks like. So 3x to the power of 0, 5x to the power of 0. Now, we know that anything raised to the power of 0 gives us 1. So whatever x is here, this will always be 1. But here, it's different. It is 3 multiplied by x to the power of 0. So whatever is in here is also going to be 1, but that's just going to equal 3. Right? So the parentheses are the things that made all the difference, and that's why value of a is bigger. Just make sure, yeah, the value of a is bigger because it's 3, value of b is 1. Just make sure you don't do this by mistake in your calculator when you're solving different questions. Don't put things in parentheses and raise them to a power, because it will take the power of the whole thing rather than take the power of this number, for example. Now, question number 3 looks intimidating. This actually looks easy, but then it becomes hard, and then you realize, oh, it's actually easy. So whenever you see a question like this, right, you want to find the value of that. Try going for the greatest common factor. Try finding the greatest common factor. Now, we can't find the greatest common factor because we have 199 here standing in our way, while we have the 98s perfectly aligned. Don't do this and go, oh, that's 1, because that will just make things harder, actually. So what do we do instead? Let's try and make these numbers look closer to these numbers, right? So how are we going to do that? Well, 2 to the power of 100 is literally the same thing as, for example, 2 to the power of 98 times 2 squared. Because this is a rule in exponents. We're not gonna multiply the squares or the power of 98. We're just gonna add them, and that will be equivalent to 2 to the power of 100. So now we do the same. We plug this instead to the top. So we're gonna have 2 to the power of 98 times 2 squared minus 2 to the power of 98, which is the original one. And then over that, we're going to do the same thing here with 99. It is the same as 2 to the power of 98 times 2 without an exponent, because when there's no exponent, you assume it's 1. You assume that there's a 1 here. And if you want, I'll just put it for the sake of simplicity. This equals 2 minus 2 to the power of 98. Right? And now we can take this and find the greatest common factor of it. And I also took the arrow with me. I'll just remove that. And you guys can ignore this whole section, so I'll remove it as well. Alright. So, take the greatest common factor of the whole thing. And that will be 2 to the power of 98. If you take this out, this all of a sudden becomes 1. Right? This all of a sudden becomes 1. And do the same thing below. 2 to the power of 98. This becomes 1. And this becomes 1. So what you end up having is 2 squared minus 1 over 2 minus 1, which equals 4 minus 1 over 1. And that's just 3 over 1, which is 3. And that is it. Yeah. It actually might look like it's simple, but then it's hard, but then it's actually really simple. Just remember the greatest common factor thing. Try to make things look like each other so that you simplify. That's literally what simplification is. Making things look like each other. So your answer here is going to be 3. Now you guys already know about these ones, my favorite types of questions. Free questions. Sometimes they're hard on the actual exam, but most of the time they're actually really easy. Like in this time, they're actually really easy. The maximum and minimum temperatures in April of some Arab and world countries. The maximum is in orange, the minimum is in blue, and we have some Arab and world capitals. I said countries, it's capitals. And the reason I said countries is because I saw Algeria here. I'm pretty sure that's not a capital, but sure enough. What's the capital of Algeria? Let me know in the comments. I have no idea. Alright. The greatest temperature is in where? Let's look around. Oh my god. Surprise, surprise. It's in Riyadh. So, C. Then we have question number 5. The difference between the maximum temperatures in Riyadh and Moscow is... Alright. So, we have Riyadh, where it is 40. And then we have Moscow, which is 10 and a bit, right? It's 10 and a bit. Okay, maybe my drawing is not that great, but it's kind of supposed to be 15. And how would you know that, right? If, let's say, the exam guy's drawing was also not nice. Well, we have full numbers here, so it's not going to be 12, it's not going to be 17, for example. You can just see that from the choices. So, 40 minus 15. Let's do it classical way. That is 5, and that's 25. Alright? Hopefully you guys know how to subtract like this, and if you don't, well, there it is. There you have 25, and that's D. Now, the next question, although it relates to the graph, might not be so free. And that's because we have the word mean here. The mean of the minimum temperatures in Riyadh and Cairo is what? So if you don't know what that word means, it's not a free question. If you don't know what mean means, it's not a free question. I don't know, that sounded weird, but if you don't know what it means, then this is your sign to go learn about the mean, mode, and median, and range. This is your sign. They are very important, and they make questions like this incredibly easy. So, mean means average. What the hell is even this? All right, it means average. An average is, for example, if you have x and x, right? The average of x and x is x plus x over 2. Why 2? Because we have x and x. If we had a third x here, we would add it, and this would be 3, right? So it's adding everything together and then dividing it by however together is, or whatever together is. So that's how you find the average of literally anything. And they don't want to find the average of everything or anything. They want to find the average of the minimum temperatures in Riyadh and Cairo. So let's go back to our graph. I've made a correction here. If you've noticed, this was all the way here and now it's here. So yeah, don't get mad at me. But say this is 25. All right. Let's just pretend that it is. All right. I did my best drawing this graph and it wasn't a very good job. So say this is 25 and this is the minimum temperature in Riyadh. And then in Cairo you have 15. Right? I mean, that does look like 15, doesn't it? And also you can know that from the choices. They are whole numbers. So then we go back. Where am I going? And we do the same thing that we did with the x's. We have 25 plus 15 over 2, because there are two numbers, right? And we're adding them together. 25 plus 15, that is 40. And 40 divided by 2, that is 20. So, as you can see, if you know what mean means, this question is actually pretty simple. And its answer is also as simple. A very beautiful number, 20. In the opposite figure, the measure of the angle AMO plus BMH is equals to 140, and AMC to DMO, or the ratio of AMC to DMO is 2 to 3, and then CMH is equals to what? Angle CMH, right? We're talking about angles here. So we're given that AMO is equals to BMH. That's cool. And we're also given, it's not equal, we're given that it's 140, right? Like adding them together is 140, but we're also given that they're equal. Why? Because there's a rule with angles. Opposite angles are equal, so this is equals to this, right? Which means that this is 70 and this is 70. Why? Because 140 divided by 2, 70, right? So we have that, and then we have the AMC to DMO is 2 to 3. Here's AMC, here's DMO. Let's say instead of having a very random 2 to 3 ratio, let's put this as 2x and this as 3x, which is basically the same thing, because that ratio means that if that number, the angle number of AMC was multiplied to a number, it's kind of like 2 times that number, while that other one, which is DMO, is like 3 times that number, right? It's the same thing, we're just following the ratio. But this quantifies or adds a coefficient to the ratio so that we can use it in an equation. And now we're going to use it in an equation. So what we're looking for is CMH, right? And that also means that if we find 3x, we can find it. And yeah, like we can find it through that, for example. Also, this whole angle is 180, right? Because it's a straight line. So if we can find this angle, we can find this, because we'll just take it away from 70 and or add it to 70 minus 180 and we'll find it. So keeping that in mind, what we're going to do is move this 2x over here, because these two are equal, right? So we're not wrong when doing that. And so we can start the equation. We can actually just take this whole segment, right? And this will equals to 100, oh wait, right here, yeah. This equals to 180 as well, this segment. Alright, so we have 2x plus 3x plus 70 is equals to 180. Now we solve for the x. Finding the x will help us multiply it by 3x and then we can find this, right? So this is going to be 5x, 2x plus 3x plus 70 is equals to 180. Take the 70, you get 5x is equals to 110, and divide both sides by 5. 110 divided by 5, that is 22. And now we have 22, so that is x is equals to 22. Alright, so then 3x, so that is 3 multiplied by 22, and that is 66. And through a very weird method, but it worked, for me at least. If you have a better method, please do share it in the comments. We find this number, and then we can find this. We've used all of the givens to find it. Now, you can argue that there are easier methods, and if you have them, please add them in the comments, but I just find this to be one that uses all of the given information, and so you're kind of sure of it, and so the moment you're done with it, you can just go, 66, we're good. So, yeah, 7C. Now, question number 8. In the opposite figure, the three squares are equal in area. The sum of their areas is 12 centimeters squared. Then the perimeter of the figure is what? Alright, so we have three squares. 1, 2, 3. The sum of their areas is 12. So this is pretty straightforward. Let's divide 12 by 3, right? That's 4. So that means that the area of each square is 4. Now remember, an area of the square is s squared. And if we take the roots, s is 2. So one side length of a square, of each square, is going to be 2. So what does that look like? It looks like this. 2, 2, 2, 2, 2, and such until all of them. But remember that they're asking for the perimeter. So you're not going to just count every side length. You're going to count the exterior lengths or side lengths only. How many ones do we have? We got 1, 2, 3. This is kind of a half. 4, or you could say 5 now. 6, 7, 8. We've got 8. Counting the 2 halves as 1. So we have 8 side lengths, and each side length, or not literally each, but you could say that it's 8, that it's 2, right? So 2 by 8, that is equals to 16. Aha. And we have the perimeter. As easy as it gets. The trick in this question is very simple. Just don't count the interior side lengths that really you don't care about when you're looking for the perimeter. That's really it. Alright, question number 9. If these are two concentric circles at M, concentric is a cool word, but it literally just means that they have the same center, then the area of the shaded part in terms of pi is what? Now, guys, please appreciate this shaded part. It actually took me a long time to do. I know there are a few holes every now and then, but anyways. So, there is a mistake in this question. If you try to solve it properly, and how do you solve it properly? You take the radius of this circle, the radius of this circle, I mean the area of this circle, the area of this circle, and you subtract them. You get the area of the shaded part. Easy enough. But to do that, we have the diameter, right? So we can do that. We're going to take half of 3 and half of 2, and those will give us the radiuses, right? And then we can do the pi r squared. Easy enough. The problem is, if you do that, you get none of the choices. And that's where the mistake is in the book, which I'm correcting for you guys now once and for all, because I struggled so much with this question and there's actually no correct answer. So this is not diameter. This should be radius. And this is the only way that I could explain this question. Why? Because now, if these two are radiuses, right? We take the square. I guess we're going to have to do it in y. Alright, we take the square. This is 9. This is 25. And you have 25 pi minus 9 pi. That is equals to 16 pi. And that is one of the answer choices, A. And that is the answer in the book. So I believe that they've simply made a mistake, and this is me correcting it for you guys. It's supposed to be radius. I hope you didn't struggle with this question until you found the video, but if that's the case, I'm very sorry. It's literally just a mistake, and that's how you do it. You get any question about any two geometric figures that are interconnected and you need the area between them. All you have to do is subtract the areas of the given ones, and that's that. Now, moving on to question number 10, the final question of this video. Be sure to check out the other videos if you need to solve some more questions. Also, I will be posting by next week. Again, sorry if I delay it a bit, but hopefully I'll become more and more consistent as the time goes. Anyways, which of the following rational numbers is between 1/5 and 2/5? Now, I'm going to use the book method to solve this, and it's actually the coolest method. So, let's check it out. I don't know what this is. Right, so 1/5 and 2/5, right? And here we have the choices. So 1/5 is the same as saying 2/10, right? If you multiply both sides, both top and bottom by 2, you get 2/10. So that means it's not this. Oh, yeah, we're using process of elimination. And 2/5 is the same as 4/10 if you multiply top and bottom by 2. And 4/10 is the same as 0.4, right? So it's not this. And now we're left with 0.3 and 1/10. Alright, and since we're left with those two numbers, we can actually also eliminate again. Now, 2/10 is equivalent to 0.2. And so we have 0.2 and 0.4. And so, guess what's the number between them? 0.3. Does that make sense? 0.2 to 0.4 has 0.3. I really like this method because it's just utilizing your knowledge of ratio. Try to constantly, whenever you can or whenever you get stuck, relate the choices to the question. Most of the time you're not going to need that, but whenever you're really stuck, it will really help you make some either really cool guesses or just proceed in a process of elimination and then using logic again. So you don't have to stick to one thing till the end. So if you used process of elimination for two choices, doesn't mean you need to keep doing it. Maybe at some point you don't need it anymore. Like this. Like most people wouldn't go back and look, oh, 2/10 has 0.2. But you have to be not like most people. That's why you're watching my videos. And so, with that, we conclude the math questions for today. Thank you so much, you guys, for tuning in. Your support through my absence has been felt. It has been immense. I've been receiving multiple emails, and though they are just requesting more videos, it's nice to know that my videos are helpful to you guys. I'm glad that I can help, and I know that I say this phrase a lot, but it's true. I'm really glad I could help. I will link below my PayPal for your donations, as long as my email, and the new linkage will be of my Instagram. If you guys want to talk to me or follow me, go ahead. You can text me anything. You don't have to. It doesn't have to be about the videos. And yeah, I'll see you guys soon. Hopefully, the next video will be another English model, and then we're going to do another math model and such and such. Hopefully, we can get done with this book very soon. See you guys in the next time. يوفقكم الله جميعا.